Okay, so this video is going to just go over some of the things that we've been talking about over the last couple of weeks in order to prepare you for our upcoming test or quiz. Okay, so the first thing I want to talk to you about is BEDMAS. So here's one example where we would need to use BEDMAS, and we know that BEDMAS is what we need to use here because there's only one variable in this equation, which is x, and it's totally by itself, meaning there's x on one side of the equal sign and nothing else around it. So that's how we know that BEDMAS is what we need here. So BEDMAS says that we need to start by evaluating what's in the brackets first. That's what the B is there. So in our case, that's 13 minus 5. 13 minus 5 is 8. So now we have 2 times 8 squared equals x. And now we evaluate our exponents. So 8 squared is 64, so that's next. And then lastly, we have our multiplication, which is 2 times 64, giving us 128. So notice what I've done here where I've matched the color with the letters in BEDMAS to help you keep track of what we're doing in what order. Okay, here's another example. 5 plus 4 divided by the square root of 9 is equal to x. In this example, it's easier to simplify everything that we can simplify first before we continue. So the first thing we're going to simplify is the square root of 9. Because it goes evenly, it's going to be simple to evaluate first. So the square root of 9 is 3. And then now we're ready to deal with the numerator. 5 plus 4 on the top is 9. And so now we're ready to do 9 divided by 3 to get x. So notice that we actually did addition before we did division. So we followed a before a d. But that's because there's really like an imaginary set of brackets around this whole numerator. 5 plus 4, since the entire thing is being divided by 3, we have to do 5 plus 4 first before we can divide by 3. Okay, so 5 plus 4 is 9. 9 divided by 3 is 3. So that means that x must be 3. Another example like this, here we have x equals and then a whole bunch of things on the right hand side. Notice that I can have something equals x or x equals something. It doesn't matter. We just have two sides of an equation, but here we still see x is totally by itself on one side of that equation. So that means that we're going to use BEDMAS. Okay, so BEDMAS says first we start in the brackets, so we have 15 minus 3 squared first, but because 15 minus 3 squared involves subtraction and exponents, then BEDMAS says we have to deal with those exponents before we can do the subtraction. So we're starting with brackets, but within those brackets we need to start with exponents. So that 3 squared is 9. That's how we evaluate that exponent. And now we're ready for the subtraction inside the brackets. 15 minus 9 is 6. So now we have 2 times 6 plus 4. BEDMAS says that we have to do the multiplication before we do the plus 4. So 2 times 6 is 12. Now we're ready to add that 4 and we get 16. Okay, so there's 3 examples of BEDMAS. Let's do one more example of BEDMAS like this. X equals 3 times 5 squared, all divided by 20 minus 3 times 5. Again, we can simplify things a little bit first. So here we have 5 squared. We're evaluating to get 25. Notice we have to do 5 squared first. We can't do 3 times 5, okay? Because BEDMAS says you do exponents before you do multiplication. So we have to do 5 squared before we can do 3 times 5. So 5 squared is 25. Now on the bottom we have 20 minus 3 times 5. We have to do the multiplication first. 3 times 5 is 15. That's the part that's also in the brackets. Okay, so now continuing, again we're going to simplify the numerator and we're going to simplify the denominator before we do the division. It's kind of like there's brackets around the whole numerator since the entire numerator is being divided by the entire denominator, vice versa. So 3 times 25 is 75, we're doing that multiplication, and 20 minus 15 is 5, we're doing that addition and subtraction, and now that we have the numerator and denominator simplified, we're ready to divide. 75 divided by 5 is 15. Okay, so there's a whole bunch of examples of BEDMAS. Now, the next thing I want you to do is pause this video and complete question number 1 on your sheet. So question number 1 on your sheet looks like this. So there's a couple of BEDMAS questions there for you that I'd like you to do on your own. So go ahead and press pause. When you're done, you're going to ask the teacher to see if you got the answers correct. And if they are correct, then you just keep continuing to play the video, and there'll be other kinds of questions there for you. And if any of them are not correct, I want you to go back and watch that BEDMAS part of the video again, and then try number 1 again. Okay, so don't move on until you're ready with BEDMAS. Okay, so go ahead and hit pause. Okay, so now what we're going to do is we're going to look at SAMDEB. So here's an example where we'd have to use SAMDEB, and we recognize it because x, which is the only variable in this equation, is not by itself. There's a 4 and a 7 on the same side of the equation as x. So if you compare that to the last one, see x is totally by itself. Now in this next one, x is not by itself. It has a 4 and a 7 on the same side. So because we're doing SAMDEB to get x totally by itself, we need to undo everything we see in the reverse order that we would normally do it. So we're following SAMDEB instead of BEDMAS. So that means we need to get rid of this plus 7 first. We get rid of this plus 7 by subtracting 7. That will leave us with only 4x on the right, and then we have to subtract 7 on the other side to make it even, so it looks like this. Okay, so we've subtracted 7 on the right-hand side, so we subtract 7 on the left-hand side. So that leaves us with 23 minus 7 on the left, which is 16, equals 4x. Now, in order to get x by itself, we have to get rid of this multiply by 4. So we get rid of the multiply by 4 by dividing by 4. So when we do that on the right-hand side, that leaves us with just x. When we do that on the left-hand side, it leaves us with 4, because 16 divided by 4 is 4. Okay. Another example where we have to use SAMDEB. So once again here you can see n is totally not by itself. There's a 5, a 3, and a 4 all on the same side of the equation as n. So that means we need to get rid of the 3, the 4, and the 5. There's a few ways you can do this. For me, because I know that a lot of people don't like fractions, I like to get rid of the denominator first because that helps get rid of the ugliest part of the fraction first. So getting rid of this divide by 4 means that we have to multiply by 4. So multiplying by 4 makes that divide by 4 go away on the left, so then we have to multiply by 4 on the right in order to make it balanced. So 30 times 4 is 120. Now we have just 3 times 5n on the left-hand side. So that means we need to divide by 3 and we have to divide by 5. We can do those together or one at a time. So here I'm just dividing by 3 on both sides, so I get rid of the 3 on the left-hand side, and then dividing by the 3 on the right-hand side gives us 40. Then we have to divide by 5 on the other side, leaving us with 40 divided by 5 on the right, because 120 divided by 3 is 40, and now we divide by 5 and we get 8, so n must be 8. Another example of SAMDEB. Here once again we have x totally not by itself, so that means we need to follow SAMDEB. So we use SAMDEB anytime we're solving like that. With this one I have a couple of choices about how I can solve it, but again, because the denominator is the part that's really ugly, first I'm just going to simplify this 3 times 4 and get 12, and next I'm going to get rid of that denominator. So notice here what happened. So I took 3 times 4, I multiplied them together to get 12, and now here this says divide by x, so I get rid of dividing by x by multiplying by x. So that leaves us with just the numerator on the left hand side, and when we multiply by x it gets rid of the times or divide by x over here, but we have to multiply by x on the right hand side to make it balanced. So we have 12x on the right and then 2 times 3 plus 8 squared on the left. So now in order to get x by itself, I need to get rid of this 12. I can get rid of that 12 by dividing since x and 12 are being multiplied, so I divide by 12 this time. So that leaves us with the left-hand side now divided by 12 and the right-hand side with just x. Now, this part is important. We have x by itself now. So because x is by itself, now this question that I was using SAMDEB to solve, I'm now ready to use BEDMAS with, because the thing I'm looking for is by itself in the equation. So whenever the variable is by itself, you use BEDMAS. Okay. So we go ahead and use BEDMAS. It means we do the brackets first, 8 plus 3, and we get 11. Then we square it, then we multiply by 2, then we divide by 12. So 3 plus 8 is in the brackets, then 2 is the exponent, then we're going to multiply by 2 and divide by 12. That's division and multiplication. That gives us about 20.17. Okay, notice how I put the little squiggly equal sign? That means that it's only approximately equal to that. Sorry about that. Okay, next one. So this is pi r squared is equal to 55.549. So we need to get r by itself because r is the only unknown in this equation. So that means we need to get rid of the square and we need to get rid of the pi. So you do those one at a time. First, what we're going to do is divide by pi because we are doing SAMDEB. So that means that we undo the multiplication before we undo the exponents. See, multiplication comes before exponents. So we get r squared equals 55.549 divided by pi, since once I divide by this side, divide by pi on this side, then I'm left with just r squared. And that gives me this number. It's about 17.7. Notice the squiggly equal sign, because it's only approximately equal. Now to get rid of the square, I have to do the square root. So The square root of r squared is just r, and the square root of 17.7 is about 4.2. Okay, so there's a whole bunch of examples of SAMDED. So now what I'd like you to do is pause the video again, and now you're going to complete number 2 on your sheet. So that's the one that looks like this. Okay, so you're solving for all of these in all these equations. So you're solving for x in all of them. So you're going to do that next. Please pause the video before you continue. And again, check your answer before you move on. Okay, and then come back to the video when you're ready. So the next kind of question I'd like to review is the question type that has to do with patterning. So here I'll give you just a minute to think about what the pattern is, and I'll be silent while you do that. Okay, so here we're looking at the rule, and we see that in each of these patterns, for position 1, there's 2 blue tiles and 9 red tiles. In position 2, there's 2 blue tiles again, and 2 groups of 9 red tiles, so that means that there's 18 red tiles, which means that there's 20 tiles in total, because I have 9 here, and then 2 more, so together that makes 20. And now in the third position, I have 3 groups of 9, plus these extra little 2. So that means that the rule is going to be position number times 9, because that tells me how many groups of 9 I have. Okay? And then I have these 2 all the time that I have to tack on to the end when I'm looking for the total. So in this one, the total is 9 plus 2. In this one, the total is 2 groups of 9 plus 2. And in this one, the total is 3 groups of 9 plus 2. So that means that the rule is the number of tiles, so the total number of tiles is equal to the position number times 9 plus 2. Notice that I put the plus 2 first. It doesn't matter what order we put them in. You can have 2 plus the position number times 9, or you could say the position number times 9 plus 2. That means the same thing. You're multiplying by 9 and you're adding 2 in order to get the number of tiles. Okay, so when it says what is the number of squares, that's in position 46. That means that I'm going to take that pattern rule, number of tiles equals 2 plus the position number times 9, and I'm going to put 46 where the position number was. So now I just follow BEDMAS because I'm looking for the number of tiles, and that's already by itself in the equation. So that means I'm going to multiply first before I add. So 46 times 9 first, then plus 2, and I get 416. In the next one it says what is the number of squares at position 0? So again, I look for my pattern rule, but the position number is 0, so I put that where the position number goes. And we know that 0 times 9 is just 0, so then we add 2, and we get that the total number of tiles is just 2. So you'll notice that position 0 always is just the part of the rule that stays the same every time. Okay, it's always that little constant at the beginning or end of the rule. Okay, next pattern. Again, I'll give you just a moment to look at this pattern and decide how is the pattern growing, what is the rule. Okay, so again, in this one, we look at the part that's staying the same, 3, 3, 3. There's 3 blue tiles every time. Okay, so that's the part that's staying the same. And in each pattern, we can see that there's 1, 2, 3, 4 red tiles in position 1. In position 2, we have 2 groups of 4 red tiles. In position 3, we have 3 groups of 4 red tiles. Okay, so that means that the rule is we have position number times 4, because that tells us how many groups of 4 tiles we have, plus an extra 3. So we have the total number of tiles in this case would be 4 plus 3, which is 7. In this case, it would be 2 times 4, which is 8, plus 3. In position 3, that means that we have 3 groups of 4, so that's 12 plus 3. So the position number times 4, because that tells us how many groups of 4 we have, plus 3 is the total number of tiles. So what is the number of squares that's at position 51? Well, we take this rule and we put 51 where the position number goes. So we have 51 times 4 plus 3 is the total number of tiles. So we do BEDMAS, so that means that we're multiplying first because the number of tiles is what we're looking for, and that's by itself in the equation. So we multiply first and then we add 3. We get 207 is the total number of tiles. Okay, what is the number of squares that's at position 0? So once again, if you remember from the previous slide, that means that we're looking at the part that's not changing. So because 0, the 0th position, would have 0 groups of 4 plus 3. So 0 groups of 4 means 0 times 4, and then plus 3 means that we have 3 tiles at position 0. Okay, one more pattern. Again, I'll be silent while you think about this one for a minute. What is the rule?